Good day, everyone. Welcome to our online math tutorial series of math lessons for grade 10. Tara, sabay-sabay tayong matuto at home. This is grade 10 mathematics, quarter 1, module 6, finding the nth term of a geometric sequence and geometric means. I am teacher Marian M. Guerrero, your math teacher for today. As we start our lesson for today, kindly prepare the following: your math module, piece of paper, your pen, and your notebook. In this lesson, you are expected to familiarize the formulas in finding terms of geometric sequence, find the nth term of a geometric sequence, and determine the geometric mean or means of a geometric sequence. Before we start, let us have first a recall of what we have discussed from last week. Number 1, a geometric sequence is a set of terms in which each term after the first is obtained by multiplying the preceding term by the same fixed number called the common ratio. And the common ratio is obtained by dividing a term to its preceding term. Let us now have an activity. Find the next term of the geometric sequence. Number 1, 5, 10, 20. For us to get the next term, we have to divide the second term to the first term to get the common ratio. 10 divided by 5 is 2, and 20 divided by 10 is 2. Therefore, the common ratio is 2. We will now use it to multiply from the last term, and 20 times 2 is equal to 40. Therefore, the next term of the sequence is 40. Number 2, 3, 9, 27. Let us get the common ratio. 9 divided by 3 is 3, and 27 divided by 9 is also 3. Using the common ratio, let us multiply it to the last term, which is 27, and 27 times 3 is equal to 81. Number 3, 625, 125, 25. Let us get the common ratio. 125 all over 625 is 125 over 625, wherein when we simplify it, that will come up with 1/5. Therefore, the common ratio is 1/5. Multiply it to the last term given. 25 times 1/5 will give us 5. Thus, the last term is 5. Now, what if I'm going to ask for the 10th term or 20th term and 100th term respectively? Are you going to use the same method? To easily find the nth term of a geometric sequence, let us derive the formula for it. Let us consider the problem below. What is the 20th term of the sequence 5, 10, 20, 40? Let us now derive a formula which may help us find an unknown term of a geometric sequence. Take a look at the table below. This table, we have here the terms of the sequence 5, 10, 20, and 40. For the nth term, we have a sub n. And for the first term, that is just 5, the pattern is 5 and can be written as 5 times 2 raised to 0, wherein 2 raised to 0 is always equal to 1. Any number raised to 0 is 1. For the second term, which is 10, that is obtained when we multiply 2 from the last term. So we have here 5 times 2 for the pattern and can be written as 5 times 2 raised to 1. For the third term, 20, that is obtained by multiplying another 2 from the last term. And the last term is written as 5 times 2. Then that is also 5 times 2 times 2. Can be written as 5 times 2 raised to 2. And for the fourth term, which is 40, that can be written as 5 times 2 times 2 times 2, or 5 times 2 raised to 3. Now, given an a sub n, that is 5 times 2 times 2 up to the last times 2, and can be written as 5 times 2 raised to n minus 1. N is the number of term, wherein A sub n now is equal to 5 times 2 raised to n minus 1, and 5 is our first term, and 2 is our common ratio. Therefore, that can be written as a sub n is equal to a sub 1 times r raised to n minus 1. Now, the formula in finding the nth term of a geometric sequence is given by a sub n is equal to a sub 1 times r raised to n minus 1, where a sub n is the nth term, a sub 1 is the first term, r is the common ratio, and n is the number of terms. For example, what is the 20th term of the sequence 5, 10, 20, 40? So let us answer the question that we've had a while ago. Using the formula, let us state the given. Our a sub 1 or the first term is 5. The common ratio is 2. And our n, we're looking for the 20th term, thus n is equal to 20. Using the formula, let us substitute the given. A sub n is a sub 20 is equal to a sub 1, which is 5. The ratio is 2, and n is 20 minus 1. Simplifying the exponent, that is a sub 20, is equal to 5 times 2 raised to 19. Then, let us simplify 2 raised to 19. That is, a sub 20 be equal to 5 times 524,288. Then multiply, this will come up with 2,621,440. Therefore, we can now answer that the 20th term of the sequence is 2,621,440. Another example, using the geometric sequence 2, 8, 32, find a sub 6. Given, our first term is 2, r is 4, that is obtained when we divide 8 divided by 2. And n is equal to 6 since we're looking for the sixth term of the sequence. Using the formula, let us substitute all the given. We have a sub 6 is equal to 2 times 4 raised to 6 minus 1. Let us simplify the difference of 6 minus 1, that is a sub 6 is equal to 2 times 4 raised to 5. Then simplify the exponents. We have a sub 6 be equal to 2 times 1024. That is 4 raised to 5. And then lastly, let us multiply. We'll come up with a sub 6 is equal to 2048. Therefore, the sixth term of the sequence is 2048. Another example, what is the seventh term of a geometric sequence whose fourth term is 128 and a common ratio equal to 4? Notice that in this problem, the only given is the fourth term, which is 128, and the common ratio, which is equal to 4. So in this case, we have to determine first the a sub 1, then after that, we can now find for a sub 7 or the seventh term. Okay, given. We have here given a sub n or the fourth term, which is 128, the common ratio of 4, and n, which is equal to 4, which is the fourth term of the sequence, which is 128. Now, using again the formula, we have here substitute, that will become 128, our a sub n, is equal to a sub 1. So, a sub 1 is what we are looking for in this problem, times 4, the common ratio, raised to n minus 1, that is 4 minus 1. Then, we'll have 128 equal to a sub 1 times 4 raised to 3. Simplifying the exponent, that is 128 is equal to a sub 1 times 64. Thus, let us divide both sides by 64 so that we'll come up with a sub 1 be equal to 2. So meaning the first term of our sequence is 2, we can now get the seventh term of the sequence. Continuing, now that we have a sub 1, which is 2, we can now find a sub 7. Given our a sub 1, which is equal to 2, the common ratio is still 4, and n, we are looking for the seventh term. Using the formula, let us substitute. That is a sub n equal to 2 times 4 raised to 7 minus 1. Simplify 7 minus 1, that will become a sub 7 is equal to 2 times 4 raised to 6. And then, simplifying the exponent, we have a sub 7 is equal to 2 times 4096. And multiplying the two factors, we have a sub 7 is equal to 8192. Therefore, the seventh term of the sequence is 8192. Now that we have identified the nth term of a sequence, let us focus now on the next lesson, which is all about the geometric means. The first and the last terms of a geometric sequence is called the extremes, and the terms in between the extremes are called the geometric means. For example, we have 5, 10, 20, 40, 80. 5 and 80 are what we call the geometric extremes, and 10, 20, 40 are what we call the geometric means. In identifying the geometric means of a sequence, we first get the common ratio. And for that, we use this formula. Common ratio, or R, is equal to n minus k root of a sub n all over a sub k, wherein n is the number of terms, k is equal to 1 since it is the first term replacement, r is equal to the common ratio. For example, determine the geometric means of the sequence 2 and then 2 terms 250. Using the formula, let us state the given. We have a sub k, which is equal to 2, that is the first term, thus k is equal to 1. And a sub n, the last term given, which is 250, and n is equal to 4 since that is the fourth term of the sequence. Using now our formula, let us identify and substitute the given. R now will be equal to 4 minus 1 root of 250 all over 2. Divide the terms we have here. R is equal to the cube root of 125. And the cube root of 125 is equal to 5. Meaning, the common ratio of the sequence is 5. Using this ratio, we can now identify the geometric means of the sequence. For us to get a sub 2, that is a sub 1 times r, that is 2 times 5, which is equal to 10. And for the next term, we will again multiply to the common ratio, which is 5. 10 times 5 is equal to 50. Therefore, the geometric means of the sequence are 10 and 50. Let us now have the last example. Determine the geometric means of the sequence. So we are looking for the first term, the third term, and the fourth term, given the second term, which is 3, and the fifth term, which is 1 over 9. Using again the formula, let us have the given. Our a sub k is equal to 3, which is k is equal to 2 because 3 is the second term of the sequence. And a sub n, which is the last term, is 1 over 9, which is the fifth term of the sequence, thus n is equal to 5. And then, let us substitute it to our formula. We will come up with r is equal to 5 minus 2 root of 1 over 9 all over 3. Simplify, that is, r is equal to the cube root of 1/9 times 1/3. And then, simplifying, we have r is equal to the cube root of 1 all over 27. And the cube root of 1 all over 27 is equal to 1/3. Therefore, the common ratio is equal to 1/3. Now, let us get the first term. The first term can be obtained when we divide the second term to the common ratio. The second term is 3, divide the common ratio, which is 1/3, and that it will be equal to 9. And for the third term, we will multiply the common ratio from the second term, that is 3 times 1/3, which is equal to 1. And for the fourth term, multiply again to the common ratio, that is 1 times 1/3, which is equal to 1/3. Therefore, the geometric means or the missing terms of the sequence are 9, 1, 1/3. So with that, let us synthesize our lesson for today. The formula in finding the nth term of a geometric sequence is given by a sub n is equal to a sub 1 times r raised to n minus 1. And we use this formula r is equal to the n minus k root of a sub n all over a sub k to find the common ratio in identifying the geometric means. With these examples, I know that you are ready to answer your module. And now, I would like to thank you for listening to our lesson. Thank you and God bless.